Welcome all of you to SST College of Arts and Commerce. This is SST Edupedia. Myself Krishna Salgaonkar. I am an assistant professor from Department of Science, Information Technology and Computer Science. Let's start with the topic. Today I am going to discuss course Digital Image Processing, which is a part of TYCS semester 6 syllabus. And the topic which I am going to cover is convolution and correlation. So let's start with the topic. Here I am going to cover your basic concept, what is convolution and what is correlation, and few example little bit convolution as well as correlation. Convolution and correlation are mathematical operations that are commonly used in image processing, signal processing and other fields. See, basically our images are stored as a matrix, number of matrix, and when we apply some effect to our images, like if we make the image blur or if we increase the brightness and all that time we get one more matrix and we do the multiplication of both the matrix to get a new matrix, and that matrix is with the effect which you want to apply. To clarify the things further, now I am just going to my next slides. Convolution is a mathematical operation that combines two functions typically used to model the response of an system to an input. In image processing, convolution is used to apply a filter to an image which can be used to sharpen, blur or detect edges in the image. So we have an image. If you want to apply some filter to that image like sharpen or blue, or you want to detect the edges in the image, that time you have to do the convolution. Convolution is a mathematical operation and that combines two functions to give you a new functions. The convolution operation is performed by sliding the filter over the image element wise, multiplying the value in the filter with the corresponding values in the image and summing the results. Basically we have one more matrix for convolution and our original image matrix. So what we do, we filter over this matrix on our original matrix. Let's see the example which is there in the next slide, so it will be more clear to you. So you can see this is an example for convolution. This side, that yellow color matrix which you can see on the screen, that is the image matrix. It is having value 2, 2, 2, 3, then 2, 1, 3, 3, 2, 2, 1, 2 and 1, 3, 2, 2. This is a matrix, and that effect which I want to apply, I can apply using this matrix, that is 1, 1, 1, minus 1, 2, 1 and minus 1, minus 1 and 1. When I want to do the convolution, I have to use both the matrix. See, in the image you can see where I combine both the matrix. So this overlapping elements I multiply. So this 2 will get multiplied with this 2, so you get 4 over here, that is in red color outline you can see. Then this 1 and this 2 I multiplied, so I get 2. Then minus 1 and 2 I multiplied, we get minus 2, and here again the last element is 1, 1 we multiplied and we get 1. Now if you add all this element, you get 5 over here. This is the first step. Okay, then you have to shift the effect matrix, that is this brown color matrix, to the next position. So just we will see into the next slide. The same thing I shifted to the next position. Again the overlapping values I have to multiply, and then I have to do the total of this. The total of this will be 4. So I have to keep on shifting the matrix and I have to keep on calculating the values. So once all the shiftings are done, you get this final convolution matrix, which is 5, 4, 4, minus 2. Now I have the original image, I have that convolution to apply the effects, I have that matrix, then I will do the convolution of both the things and I get this new matrix. In this you can see the filter is applied. Okay, now this is all about the convolution. Now the next one is correlation. Correlation, on the other hand, is a measure of similarities between two signals. In image processing, correlation is used to measure the similarity between an image and a template. The correlation operation is performed by sliding the template over the image and computing the dot product between the template and the image at each position. It is moreover similar to our convolution, but here we measure the similarities between the signals. Whatever signals we are using, we will try to find out the similarities between the two signals. The result is a new image with the same dimensions as the original image, which represents the correlation between the image and the template. We will see this example. Again the same thing. From my left hand side, you can see the correlation matrix, that is 1 minus 1 minus 1 1 2 minus 1 1 1 1, and my right hand side on the screen you can see the image matrix, that is 2 2 2 3 2 1 3 3 2 2 1 2 1 3 2 2. Now again I have to do the procedure which I followed for the convolution. So here if you check, so the overlapping things are multiplied. So here this 2 is multiplied with this 2, and then if I do the total of this, I will get 5. That is the first step. Then second step, I have to shift the matrix. So see, if you check, the matrix is over here, and now I am shifting the matrix to the next position. I will calculate this part, and this part will get multiplied, and now I am doing the total of this, so it will come 10. This way, one step I have to keep on moving the matrix. One step is over, then I have to slide it down and then down. That way I have to complete the whole matrix. So the correlation matrix, I will get this. So actually in the original matrix, that is my original image, I apply some effect matrix, multiplying or whatever things correlation. After correlating this two, I will get one more matrix which is having that effects. For understanding convolution and correlation in a better way, I have some examples that I will share with you. There are many examples of convolution and correlation in image processing, signal processing, and the other fields. Convolution example. One example of convolution in image processing is using a filter to sharpen an image. So if you want to sharpen an image, you can use a convolution. A command filter used for sharpening is the Sobel filter, which is a 3x3 matrix that is convolved with the image to detect the edges. So basically you have one 3x3 matrix which is already defined, that you are going to convolve with your original image, and you get a new image. In that image you can easily detect the edges. The convolution operation is performed by sliding the filter over the image, element wise multiplying the values in the filter with the corresponding values in the image, and summing the result. The result is a new image with enhanced edges. With this diagram it will be clear. See, my original image is blur. I use this convolution. I did the convolution with this matrix, that is 1 by 9 1 1 1 1 1 1, and after doing the convolution of the original matrix and this, I get a new image which is little better than the original image. If you see, it is more pixelated and it is less pixelated. Convolution example. Another example of convolution in image processing is using a filter to blur an image. You can use the convolution for blurring the image. A common filter used for a blur is the Gaussian blur, which is a square matrix with a Gaussian distribution of weights. The convolution operation is performed by sliding the filter over the image, element wise multiplying the values in the filter with the corresponding values in the image. and summing the result is a new image with a blur effect. So you will have the original image when you apply this blur matrix with convol. We are going to do a convolution with the blur matrix, and then you get a new image which is blur. So original clear image you are going to blur using this technique. Now we will proceed toward the correlation example. An example of correlation in image processing is using a template matching to find an object in an image. A template of the object is defined and the correlation operation is performed by sliding the template over the image and computing the dot product between the template and the image at each position. The result is a new image with the same dimension as the original image, which represents the correlation between the image and the template. The highest correlation value in the new image corresponds to the position of the object in the original image. So here basically we will compare the two images. So we are going to compare the image with the given template. In a signal processing, an example of convolution is filtering a signal. For example, a sound signal by a filter extract certain frequencies. The convolution operation is performed by multiplying the signal with the filter and summing the result. This is one more example for convolution. Now I will show you the example for correlation. So this is how the correlation is done with the image. So you can see the edges are detected in this final output. So now let's summarize what we learned today. Convolution is an operation that combines two functions which while correlation is a measure of similarities between two signals. Both of these operations are widely used in image processing, signal processing and other fields. Then convolution and correlation are mathematical operations that have many applications in image processing, signal processing and other fields. They are widely used for image filtering, image enhancement, object detection and signal filtering. Here I want to add two more things, that when you want to learn image processing, first thing you have to understand how the images are getting stored. So images are getting stored in the form of a collection of numbers, okay, and then they are going to get displayed on the screen with the help of some software. So actually inside the computer or inside the memory we are having collection of numbers. Now these numbers, when we want to apply some effect, so we are actually having some numbers with us. So when you want to apply some effects to it, we have to we have some matrix with us. So that matrix we have to multiply with our original image matrix, and that multiplication, that is convolution or correlation, produces a new matrix. In that new matrix you will get the image with the desired effects. So that is how this convolution and correlation works. Thank you everyone.